already seen some examples where our functions were given by equations, but let's see a few more. So here we have three functions, f, g, and h. And these are all polynomial functions, so we have a very good understanding of how they operate. If we want to take these sums, differences, products, quotients, well, one way we could go about this is just the way that we have been. So to take f plus g of 2, we can take f of 2 plus g of 2. And then we can say, well, f of 2, that's 2 times 2 minus 3 is 1. And g of 2, that's 2 squared minus 3 times 2 minus 10, which is negative 12. And so this is just 1 plus negative 12. So f plus g of 2 is negative 11. If we want to take f minus h of negative 1, that'll just be f of negative 1 minus h of negative 1. So we'll work out f of negative 1 is 2 times negative 1 minus 3 is negative 5. H of negative 1 is negative 1 squared minus 9, which is negative 8. And so this is just negative 5 minus negative 8, which works out to positive 3. F minus h of negative 1 is just positive 3. If we want to take g times h of 0, well, that's g of 0 times h of 0. We can work out g of 0 is 0 squared minus 3 times 0 minus 10 is negative 10. H of 0 is 0 squared minus 9 is negative 9. And so g of 0 times h of 0 is negative 10 times negative 9, which is positive 90. If we want to take h over g of 5, well, that's just going to be h of 5 over g of 5. We say h of 5 is 5 squared minus 9, works out to 16. And then g of 5 is 5 squared minus 3 times 5 minus 10. Uh-oh, that's 0. So we get 5 over 0. We can't do 5 divided by 0, though. And so this is undefined. But that won't always happen, right? We can take, for example, f over g of negative 4. That'll be f of negative 4 over g of negative 4. And then we'll say f of negative 4 is 2 times negative 4 minus 3 is negative 11. G of negative 4 is negative 4 squared minus 3 times negative 4 minus 10. That works out to 18. And so this is just negative 11 over 18, And it turns out we can't simplify that fraction, so that's just where we stop. Okay, so we've just worked out individual values for these functions. We can also write combined expressions for these functions. Here we're looking at the same three functions, f, g, and h. But now, instead of working out individual values for the sum, difference, and product, we're writing expressions for the sum, difference, and product. And we're going to simplify these expressions. So what does that look like? So I've got f plus g of x. I know I want to do f of x, 2x minus 3. I want to do g of x, x squared minus 3x minus 10. And I want to add those together. Okay, I'm adding two polynomials. Okay, when I'm adding polynomials, I can just use the associative property and drop the parentheses. So we've got 2x minus 3 plus x squared minus 3x minus 10. And then we can go through and combine like terms. So I've just got one x squared term. So I've just got x squared. And then I've got a 2x minus 3x. That's going to be a negative x. And then I've got negative 3 minus 10. That's going to be minus 13. So f plus g of x is given by the expression x squared minus x minus 13. H minus f, well, I'm going to take my h of x, x squared minus 9, and now I'm subtracting my g of x, x squared minus 3x minus 10. Here, I'm subtracting two polynomials, which means that I need to distribute the negative sign to my second polynomial. So my first one, I'll leave alone, x squared minus 9. And then in my second one, I'm going to reverse all the signs. Minus x squared plus 3x plus 10. And then I'm going to combine like terms. I've got an x squared minus x squared. Well, that's just 0. I've got a 3x, that's my only x term, so I'll have a 3x here. And then I've got negative 9 plus 10. That works out to plus 1. My h minus f of x is just 3x plus 1. And it happened that the x squared terms canceled out. What about multiplying? I can take g times h of x, and that's going to be my g of x, x squared minus 3x minus 10, multiplied by my h of x, x squared minus 9. So now I'm multiplying two polynomials. If they were two terms each, we could use the FOIL shortcut. One of them has 3 terms, so I'm going to write out my multiplication as a rectangle. So I'll need 3 columns, 2 rows. When we were factoring, we put the terms of our product inside the box, and we figured out what went outside. Here we're just multiplying. So the things we're multiplying go outside, and then the terms of our product will end up inside the box. X squared times x squared, that's x to the 4th. X squared times negative 3x, that's negative 3x to the 3rd. X squared times negative 10, that's negative 10x squared. Negative 9 times x squared, that's negative 9x squared. Negative 9 times negative 3x, that's positive 27x. Negative 9 times negative 10, that's positive 90. So my g times h of x, I'll go through here and collect like terms as I go. There's only one x to the fourth. There's only one x to the third, negative 3x to the third. There are two x squared terms. Negative 9 minus 10 is negative 19 x squared. There's only one x term, so plus 27x, and only one constant, so plus 90. So when we multiply two expressions, if they're both polynomials, we're multiplying two polynomials. We have to use that skill when we're trying to get an expression for the product function. Now, depending on what we want to do next, it might be easier to just not multiply this out. If we didn't have this simplify as much as possible instruction, this is a perfectly acceptable expression for g times h of x. But because we were told to simplify as much as possible, we had to multiply that out. Okay, so we just wrote expressions for the sum, difference, and product, but not the quotient. Well, let's see what happens when we try to write an expression for a quotient. We'd like to write an expression for g over h of x. So we'll have a fraction and put g of x in the numerator. That was x squared minus 3x minus 10. Right, this is g of x. And then we'll put h of x in the denominator. That's x squared minus 9. That's h of x. So now we have, what we're looking at here is a fraction with a polynomial numerator and a polynomial denominator. At the moment, we don't know how to simplify this. We're going to learn how to simplify this extremely soon, but at the moment we don't know, which is why this instruction told us not to try. But even unsimplified, this is a perfectly good expression for g over h of x. Right? If you gave me a value of x, I could take it and plug it in here, no problem.